Okay, so let's talk about the code for experiment 3. So the code for experiment 3, pretty much it's this. The code is very similar to the other two experiments. The only difference is that this stepper, the stepper number here, is going to be 0x08. So this is because it's in hexadecimal from this number here. So if we look at this chart, at this half step chart here, um, it's basically, which is the medium torque. So in this experiment, pretty much what we want to do is we want to implement it with a half step, right? Or one or two phases at a time. So half step. And then again, in as we had indicated in the previous videos, the stepper here when we first start is the step 1 value, right? So if we look back at this chart, the step 1 value is 1, 0, 0, 0. So if we convert that to hexadecimal, that's 8, right? So it's just 0x08. So that's why we have this. Okay, that's why we have this number here, and that's why we have this number. Okay, so then um, now since it's half step, right? This number here is going to change. So the number in between these two here is going to change. So now, what number does it change to, right? So the number that it changes to is, again, this number that we just erased right now is the steps for 120 degrees divided by 5, right? So in order to calculate that, um, let's see how to calculate that. So to get that number, the number of steps, right, before we divide it by 5, is essentially, okay, so we still have the same motor, right? We still want it to rotate 120 degrees. We still have the 64:1 ratio. The only difference is that this time it's a half step, right? So, get that. So this time it's a half step. It's a half step, right? And this half step here, and when it rotates one 360-degree turn, it takes 64 steps. Okay, so just keep that in mind. So again, we would be pretty much using the same ratio or the same number of turns here, because again, we still have 120 degrees, right? We still want to get 120 degrees out of that 360-degree turn, right? And we still have our gear ratio is still a 64 turn to 1, right? So yeah, so we still basically have, oops, we still have 21.33 turns, right? That's still the same number of turns. So the only difference is that for the number of turns, right? We have that number of turns, but for a half step, the number of steps for one turn is 64, right? So the number of one full 360-degree turn is 64 steps. So 64 steps for one turn, right? For one turn is about, let me plug into my calculator. I get 1,365.12 steps, right? So then again, we would divide it by 5. So if we go back to our code, as you can see here, our s here, our int s is 5, right? So in both of these, it's both 5. So we have to divide it by 5. So now we get, we put 1,365.12 divided by 5, and we get a number of 273 point whatever. But I'm going to round it to 273 and 273. Cool. So that's the numbers that you get, and that's how I got the numbers, right? And again, this for loop, as I had previously mentioned in the other experiment videos, this for loop is for clockwise, and this one is for counterclockwise with a delay of 500 milliseconds in between each one. Okay, so now let's get to the code for the experiment. So for the code of this experiment, pretty much we have a structure, right? And this structure contains a something called it has a we could basically interpret this structure here as a double linked list. So what is a double linked list? Um, I guess the best way to explain it, a double linked list, is if I were to show it. Okay, so a double linked list, right? A double linked list is pretty much just kind of like a list, right? So it has it in the name, it's a list. So in this list, we have a pre-step, the data that it's currently holding, and the next, right? So this is going to be for step 1, step 2, pre, our data, and our next, right? And that's going to continue up until step 8, right? Up until step 8. And it's going to have the same thing. It's going to have a pre-step, the data that it's holding, that step is holding, and the next step, right? So, okay, so I'm going to mark clockwise in yellow. Oops, that's very messy. Clockwise, right? So if it's going in clockwise, it's pretty much just going to go on to the next step, right? So it's going to go from step 1 to step 2 to step 3 to step 4 to step 5 to 6 all the way to 8. And then if it's a counterclockwise, right, it would go backwards, right? So it'd go step 8 all the way step 7, step 6, 5, 4, 3. Then we'll go step 2, and then we'll go step 1, and then from step 1 it would go to step 8, right? And for clockwise, once it gets to step 8, the next one that it would go to is step 1, and it would just be in that motion. So that is the double. That is what it's called, a double link list, and that's how we are going to interpret the code and the structure that we have. So, yeah. So that's kind of a little brief summary of what the double linked list is, and that's pretty much what we've interpreted here with this structure and this array here. So as you can tell, right? So this is basically our structure. We have our pre-step, the data that we're holding, which is essentially the number from our chart. So the number from here when we convert it to hexadecimal, right? And yeah, so as you can see, and for step 1, right, our previous, so I guess one thing before I start mentioning that is that, again, we're using an array, correct? So for arrays, when we want to call to like a specific part of the array, we're using from 0 to 7, right? Because it goes 0, 1, 2, 3, 4, 5, 6, 7. That's essentially 8 steps overall. So yeah, just wanted to clarify that. That's why we have 0, and then that's why there's no 8 in here. But yeah, so again, for step 1, right, we have our pre-step, which is step 8, and that's what this number is, step 8. And then we have our data that is currently holding, and then the next step. So yeah, and then that's pretty much the same thing for the rest of them. So the data it's holding, the previous step, and then the next step, and etc. It's going to keep on going like that. So that's what this entire structure is here. That's what that entire structure is there. And then now kind of quickly talk about the pseudocode that we had to interpret. So for the pseudocode that we had to interpret, pretty much we just had to create we had to create two variables. One of them is static steps, right, which is a pointer p, and that calls back to this array here, steps. And we set our variable I to 0, and then pretty much what we do is we have a while loop that states that when I is less than s, if the direction is going clockwise, then p, which is the step, should go on to the next step. And else, if if it's going in the counterclockwise direction, then p is going to go into the previous step, and then the stepper is going to get this data here, this data number, and we're going to set that, and it's going to go back into our main function. And then it's going to increase I by 1, so it's going to increase this I here by 1, and there's going to be a delay of 10 milliseconds. And yeah, that's pretty much it. So now that I kind of talked about the code, now let's go on to see what the actual experiment looks like. So let's get to it. So now I'm gonna show the results for the experiment. So as we can see here, we have our stepper motor, right? And this is rotating at 120 degrees. So I basically used a ruler and a protractor to create this this angle here that I have on the post-it notes, and I labeled it 120 degrees. And then this is the stepper motor here, and I indicated the this is the indicator that I added to it. But yeah, so as we can see here, it's rotating 120 degrees, right? It's touching this end here, which is, or this line here, that's one end to one end. So as you see here, it's going counterclockwise, right? It's going counterclockwise, and then it's going clockwise 120 degrees. And that's pretty much all it was supposed to do, right? It was supposed to go counterclockwise and clockwise at 120 degrees. So yeah, and as we can see here, I have my oops, let me focus. Okay, I have my my stepper motor, the driver module. I have my Tiva board here, and then I have the breadboard, and then I have the power supply module, and that's connected to the power supply, which is over there. And yeah, so again, you can see here, and I guess one more thing to note or to also add is that this in this experiment, in experiment 3, this is the motor that has the medium torque, and it has the smallest step angle and the medium torque, and it's the 1 or 2 phase at a time. So it's basically the half step one. So yeah, so just a quick show of how it works. So it hits the 120 mark, so the angle going clockwise and counterclockwise 120 degrees. So and yeah, there you go. So that's it. All right.